9.1b, evaluating nth roots of exponentials or radicals with a calculator, is going to be indirectly on the test. You can use your calculator to help you check, but you must show all your work algebraically. So 9.1a and 9.2a are evaluating nth roots in exponential or radical form without a calculator, and also doing powers using the properties we have of rational exponents without the calculator. Here's two examples. Find the expression, show all your necessary steps to solve. This is 16 to the negative 3/4 power. So the first thing you want to do is to get rid of any negative exponents. Remember, any number can be written over 1. To get rid of the negative exponent, cross over the fraction bar. So this becomes 1 over 16 to the 3/4. Now the 3/4 exponent can be pulled apart. It's a 3 on the top and then a 1/4 on the bottom. So what you're going to do is you need to cube something and take a fourth root. You get to pick and choose which order you want to do first. If you want to do 16 cubed and find that answer, then take the fourth root, you could. However, it's going to be easier for this one to break it this way. I would do 16 to the 1/4 power first and then cube that. So what I did is I took the 3/4 power and I just broke it into its two pieces. The fourth root of 16 just asks you what number 4 times gives you 16, and that's going to be 2. So this becomes 1 over 2 cubed. And then 2 cubed, be careful, is not 6. It's 2 times 2 times 2, which is 8. So this answer is 1/8. The next one here, 125 to the 1/6 power. This is actually, if you wanted to write it as a radical, we could. The radical symbol for this would be the 6th root of 125. Now what this means is what number 6 times gives you 125. Because this ends with a 5, you might think it's a 5, but if you did 5 6 times, the number would be much larger than this. Now there really are no other multiples for 125 that would be repeated, so the only way you can think about this is how can you restate this using 5s. I know that 5 to a certain power is 125, and what I'm going to do is say it's 5 cubed. Now again, we can either write this as a radical, or we could keep it as its exponent. The exponent for this was 1/6. So if we were looking at the exponent for that, how would you simplify? When the two exponents are right next to each other, you just multiply them together. Remember, this is just 3 over 1, so what we're going to have is 3 over 6. So it's going to be equal to 5 to the 3/6 power, and that's going to simplify to 5 to the 1/2 power. And ultimately this becomes the square root of 5. 9.2b and 9.1c state the domain and range of rational exponential functions and graph and to determine domain and range of nth root functions. These are really the same thing. So here we're looking at a rational exponent, and our function is f of x equals x to the 4/9 power. Now down here it's going to ask us first to find the domain and range of f of x, then find the inverse. Then it's going to say to graph the original graph and the inverse on the same coordinate axis. So let's actually start and do graphing f of x over here to the right. Now when you graph f of x, it looks something like this red function. Now they want us to find the domain and range. The domain is what are all the x values. This is a continuous graph where there's never a break in it. X can be any, all real numbers. So I'm going to say x is an element of all the real numbers, and that's my domain. Now the range, remember, deals with the y's. Notice there's no negative y activity. The y's do not start until we actually hit the origin at 0, 0. Then from there we have y activity. So on here the range, or the y's, is anything greater than or equal to 0. The next part, they want us to find f of -1. This just means the inverse. So remember, the original function was y equals x to the 4/9 power. To find the inverse, all we have to do is flip-flop x and y. So now that we've done that, how do we actually graph it? Well, to solve this for y, I need to get rid of the 4/9 power. The only way to get rid of that is to multiply by its reciprocal of 9/4 on both sides. So if you do that, we'll be left with y equals x to the 9/4 power. Now they do want us to graph that inverse function. Remember, all inverses cross over the line y equals x. So if we graph this green line, we get something like this, and that's y equals x. So what we're going to see is that the red graph here that we originally had drawn should flip over this green line, and we'll get its image. So let's put this in the graphing calculator and see what it looks like. Now when you do put this in the calculator, you get this blue sketch right here. The one thing you're going to notice by these two functions is that this component of the red graph does not exist for the blue graph or its inverse. Really, in quadrant 1 is only where we see the true replication happening. So we have it graphed, and we've done this part right here. So the last question is f of -1, and let me label that. That's our blue graph, or the inverse. Is that a function or not? If I were to do the vertical line test on the blue graph in this case, this would be a function. Therefore, we will say the inverse of this blue graph does pass the vertical line test and is a function. Now be careful, we did learn a few chapters back about a horizontal line test on an original graph. Now, technically this fails the horizontal line test, but for rational exponents, the FST book is very particular. It tells us just to look at quadrant 1. So if we just isolate and look at quadrant 1 and that's it, we would actually have done that horizontal line test just here on the red part in quadrant 1, and it would have still worked. 9.2c and 9.1d express one equation as a function of another and evaluate, and apply nth-root properties to area, volume, and rate problems. So what we have here is we're dealing with the area of a circle with the radius r. So area is pi r squared. The circumference of a circle is circumference equals 2 pi r. They want us to do two things. The first is give a formula for area in terms of circumference. So what this means is they want a formula in terms of area, so they want it to be area equals. So what we have to do, it has to say A equals, so we're going to start with this equation. So let me start with that first. A equals pi r squared. Now this formula here is in terms of the radius. They want it in terms of circumference. So we have to get rid of the radius and make it a circumference. The only way we can do that is to piggyback off of the circumference formula. We can take this formula here and solve it for r. So if I take circumference, and if I solve it for r, I would divide by 2 pi on both sides. So that would leave me with r equals circumference over 2 pi. Now, since I have this entire piece, this is r, so why don't I go to r here and just substitute it out? So I'm going to take this component here and substitute it into r here and rewrite the equation. So we will have a equals pi. Now instead of r, we put c in 2 pi, and they want us to square it. So let's simplify this formula, and we're going to write area equals pi. Let's distribute this 2, or repeat that to everything in here. Be careful, this becomes c squared, 2 squared, and pi squared. So I'm going to write c squared here, 2 squared is 4, and then pi squared. Now I can simplify this formula a bit. Here's 1 pi, here's 2. This one gets crossed off, and there's only 1 left. So when we do that, remember, this is an exponent of 1. That gets crossed, and that's left with the 1. So the final answer is area equals circumference squared over 4 pi. Now the second part of the problem, they're reversing it. Give a formula for circumference. So they want circumference this time. So I'm just going to jot that down first. Circumference equals 2 pi r. So we've taken care of this. But look at this formula. This is circumference with respect to radius. They want circumference with respect to the area. So they want us to change the r to area. The one way we can do that is piggyback off the area formula. So I'm going to jot the area formula down over here. Now what we can do, again, they want us to replace the r with the a. So why don't we take this equation and solve it for r, and then we'll plug it back into here. To get r by itself here, we need to do two things. Get rid of pi and to get rid of the squared. First thing I would do is divide both sides by pi. So then we're left with area over pi equals r squared. Now, to get r by itself, take the square root. And I'm just going to do this and take the square root of both pieces. So now we have r equals the square root of a over the square root of pi. So this piece here is going to be taken, and I'm going to substitute it right there into r. When we do that, we can rewrite the circumference formula. So it's c equals 2 pi times the square root of a over the square root of pi. Now I'm going to show you the simplifying on this. This is c equals 2 pi, and this is a. I'm going to write it as an exponent of 1/2 over pi to the 1/2. Now this is a pi, that's 1 pi, and that's a half a pi. Be careful, we actually can simplify these two for exponents. You would do 1 minus 1/2, which would be a half. So when you simplify this, you end up getting circumference equals 2, and it's pi to the 1/2 power now, and then a to the 1/2 power. So technically, this is the correct answer, written in rational exponent format. Now if I wanted to, I could write it in radical format. It's a 2. Be careful, that's square root and that's square root, so I could actually do the square root of a pi. Would also be an acceptable answer. 9.3a and b, rewrite logarithms as exponents and evaluate, or find logarithms of base 10 numbers. So let's get started with evaluating these first three. Now this is a natural log of 1 to e to the 10th power. So what you might want to do is you could rewrite the natural log as log base e if it helps you see it better. So if you do that, it's log base e of 1 over e to the 10th, and it equals something. So what I can do is our swoosh, it's going to be e to some power equals this. So when I rewrite it, it's e to some power equals 1 over e to the 10th. Now for these sides to be identical, this right here would have to have a power of a 10, but if I just had 10, it'd be on the top. How do you get it on the bottom? You would make it a negative. So the answer here is a negative 10. So we'll say this one equals negative 10. Now another way you could do it, you could also take this guy and move it to the top. If you move him to the top, it'll look like this. E to some question mark equals e to the negative 10. And therefore you can see the negative 10 a little more clearly. Let's look at this next one here. It's natural log of the 5th root of e. Again, if it helps you, let's just write it as log base e. And I'm going to write it as e to the 1/5 power right now, because that's what the 5th root is. And this thing equals something. So when I rewrite it as an exponent, I start at the base and I do my swoosh. So it's e to some power equals e to the 1/5. For these two to be identical, the exponents would have to be 1/5. So the answer here is as simple as that. It is 1/5. Now this one here is log base 8 of the 4th root of 2. So let's just go ahead and just rewrite it, and I'm going to say that this equals x. And if we do our swoosh, it's going to be 8 to some power equals this. So we're going to have 8 to the x power equals the 4th root of 2. Now I want them both to look like exponents, so I'm going to rewrite the 4th root as an exponent. So it would just be 8 to the x equals 2 to the 1/4. Now to compare them, they have to be the same base numbers. A 2 is already as simplified as it can be, but can an 8 be written as a 2? Sure. It is the same as 2 cubed. And don't forget that little x is there. And we have that. Now these two sides have to be identical, so what we need to have happen is this exponent here needs to equal this exponent here. So the answer here is going to be, what makes 3x equal 1/4? If you do your algebra and solve, what I can do is multiply this by 1/3 and multiply this by 1/3. Therefore what's going to happen is we're going to see that these 3's cancel, and all you do is you go straight across. So in this case, x equals 1/12. So the answer to this problem is 1/12. Now the next part of this is they want you to order the numbers from least to greatest, so the smallest to the largest. And here we have log base 4, log base 10, log base e, and log base 10. So what I would do is actually put these into the calculator to see what they look like. So here's what we're going to type. They're a little bit different for each one. This first one here, be careful. I do not have a log base 4 in the calculator, but you can do the base 10 conversion. If you type log of 6 divided by the log of 4, you're going to get that number. And when you do, you will get about 1.29. Now log of 6 is base 10, so I can just hit the log of 6 button on my calculator. And when you do that, you're going to get that this is about 0.778. The third one is a natural log of 6. That's just the natural log button and the 6. And that one's going to give us, this comes down to about 1.79. And the last one is log base 10 of 1/6. So hit the log button and do 1 divided by 6. When you do that one, this one comes back at a negative 0.778. So when you put them in order from least to greatest, the smallest number is the log of 1/6. So I'm going to write log of 1/6. The next smallest one, it looks like here, is the 0.778 or log of 6. So we'll put that one next. And maybe you want to cross them out as you actually write them down. Now from there we're going to have 1.29, so log base 4 of 6 we'll write as the third one. And then the last one we have is going to be the natural log of 6. And that's our answer. Now 9.3c and 9.6a are the same thing. Solve exponential equations by rewriting as logs and evaluating. So here we have two exponential equations. They want us to find the solution to the nearest 100th position. So that's the second decimal place. So let's start with this first one. Now the exponent is right here in the x, which is connected to the 8. So the first thing we want to do is just to get that by itself. So this is being multiplied by 3. To get rid of multiplication, you're just going to divide both sides by 3. When you do that, you're going to get 8 to the x equals, it'll be 12.25. Now, the only thing we have left to do is to get the x by itself, but it's connected with the base number of 8. So the key here is to take the exponent and rewrite it as a log. So what this is we start with the base of the exponent and we do our swoosh. So again, log base 8 of 12.25 equals x is what I would write. So log base 8 of 12.25 equals x. Again, our log button in the calculator is base 10, so we must do a base 10 conversion. So in the calculator, we're going to type the log of 12.25 divided by the log of 8. And when you do that, you'll find that x equals 1.20, which is to the 100th position. All right, this next problem here, we need to find e to the power of 2x equals 24.5. Now this exponent or the power is all by itself. There's nothing to get rid of. So I just jumped to my very next step is to take this exponent and rewrite it as a logarithm. So it's log base e of this number equals that. Again, I start with the base of the exponent and do my swoosh. And I'm going to write it as log base e of this. Now, hopefully you recognize log base e is just the natural log button. So you may have jumped right to this slide right here. So now the last thing we're going to do is to get x by itself, divide everything by 2. So in your calculator, take the natural log of 24.5, divide that by 2. You're going to get that x equals 1.60. 9.3e, understand logs and exponential graphs and their inverses, and then state domains, ranges, and asymptotes. So here they want us to write the equation for the inverse of f. So f can be just written as y equals 8 to the x power. So again, to find the inverse, we've already talked about, just flip-flop x and y. So this would be x equals 8 to the y. Now I need to solve it for y, but y is the exponent. When y is the exponent, the only way to get it out of there is to rewrite this as a logarithm. So start with the base of the exponent and swoosh around. So it's log base 8 of x equals y. So that's what I'm going to write, is I'm going to do the swoosh. Log base 8 of x equals y is our inverse function. This next one here wants us to consider the graph f of x equals 2 times the log of x minus 4. and just state the domain and range. And then also graph it. So let's put this in the graphing calculator and see what it looks like. And be careful, this is just y equals. This is just a different way of writing f of x. So when you graph it, here's the graph. So it's going to look like this right here. Now let's state the domain and range of this graph, but also state the asymptote. There is an asymptote here, you don't see it, but it's around at 4. So what I'm going to say here is our asymptote happens at the line of x equals 4, which will help us for the domain and range. So the domain, if you look at it, there's no x activity until after we cross the asymptote. So the domain for this graph is going to be all the x's greater than 4, but not equal to. However, the range on this graph is dealing with the y-axis. And if you notice as you travel on the y-axis, there's complete graph activity throughout. So the range on here we're going to say is the y's are all the elements of the real numbers. 9.4b and 9.6d is compute values using the continuous change model, which is the APERT, or write exponential continuous change models and solve. So in this one here, they want us to the nearest tenth of a year, find out how long it will take an investment to triple if it earns an annual interest rate of 5.25% compounded continuously. Remember, compounded continuously means APERT. And on APERT, the values stand for our beginning amount, our ending amount, our annual rate, and our time period. So what we want to do is something needs to triple. And if you want, you can just assume maybe we start with $1 and we want it to triple to $3. I'm going to put E. Our rate is 0.0525, and it's to the t power. Now, this is really just solving an exponential equation. So anything times 1 is itself, or you can divide by 1 and get rid of it and it moves over here. Well, 3 divided by 1 is still 3. So really, we just have 3 equals e to the 0.025 t power. Now we just need to rewrite this as an exponent, or as a logarithm. So it's log base e of 3 equals that. But remember, log base e is the natural log. So I'm just going to say natural log of 3 equals this as a shortcut. So natural log of 3 is 0.0525t. I can wrap this problem up by just dividing both sides by the 0.0525. And when you do that, you're going to get that t is equal to 20.9 years. 9.4a, compute values using the compound interest formula. So what they're going to have us do is redo the problem we just did that used the 5.25% interest to triple an investment. But now they want us to compound quarterly. So remember that formula was a equals p 1 plus r over n to the nt. So let's just set that up again. We're going to start with $1. We want to end with tripling it to $3. We're going to do 1 plus our rate of 0.0525. It's compounded quarterly, so it's 4 times a year. Then we have to do the n times t. Remember, t is how many years, and we don't know that, so that is actually the t. But then the n value here is how many times a year. Well, it's quarterly, so it would be 4. So let's just simplify this first part of the equation, and here's what you're going to get. And it looks like this. Now, I just actually dropped the 1 because anything times 1 is just itself. So this is actually an exponent by itself. The last thing we need to do is rewrite it as a logarithm. So what it's going to be is log base 1.013125 of 3 equals this. It might look kind of weird, but just write it. So log base 1.013125 of 3 equals 4t. Now this right here is just a number in my calculator. So what I'm going to type in my calculator though is I have to do a base 10 conversion. So it's log of 3 divided by the log of 1.013125. And here's what we get for that. Is this value here, and it equals 4t. So then to wrap this up, we just have to get t by itself. So to do that, I'm going to divide both sides by 4. And then for our final answer, what we're going to get is the time period is going to be approximately 21.06 years versus continuously was 20.9. 9.4c and 9.3d, graph base e exponents, find and graph its inverse, or solve log equations by rewriting as exponents and evaluating. So here they want us to write an equation for the inverse of f. So again, f of x is just our y value, and here's what we have. To find the inverse, we know we just flip-flop our x and our y. So now we have this. Now there's a couple ways you can do this problem. What I might do here first is actually rewrite the natural log as log base e. So let me do that. If x equals log base e of y to the fourth. The log is isolated here all by itself. There's nothing on the outside of it. So I could just rewrite it as an exponent if I wanted to. I could do e to the x power equals y to the fourth. So let's actually do that. E to the x power equals y to the fourth. Here's what it looks like. Now, how would you get rid of the fourth power here? You would just multiply by the reciprocal or take the fourth root. So it's to the 1/4 power to the 1/4. So the answer here would then look like y equals e to the x over 4. And that is the final answer. Now I do want to show you a second way to do this problem. When you're at this step, again, we just chose to rewrite it as an exponent. But what I could have done is use a property of logs and brought that 4 down. So I'm going to come back over here and take this 4 and bring it forward. So if we do that, we have x equals 4 to the natural log of y. Now to get natural log by itself, I'm going to come on in and divide by 4. So then I'm going to have x over 4 equals the natural log of y. Now I do have to just rewrite this as an exponent, but remember natural log is just log base e. So if you want to see that more visually, you can write it as log base e. And then we're just going to do our swoosh. We're going to say e to this power equals y. And when you do that, you'll get, again, e to this power equals y. And lo and behold, what happens is you do get the exact same answer. So there's multiple methods to solve that. Now 9.4d, evaluate natural log models. If we just use that same model as above, they want us to find f of 3. So very easy to find f of 3. All we need to do is put 3 in for x and evaluate. So I'm literally going to go to the calculator and type the natural log of 3 to the 4th power. And when I do that, I'm going to get that the answer is about 4.39. 9.5a and b, they want us to expand logarithms and simplify by using properties of logs, or restate the logs and simplify using different log values. So this is really just expansion. Now this first two problems are going to say they give us that log base 7 of 6 equals r, log base 7 of 9 equals s. Give the log in terms of r's and s's. So here we have log base 7 of 324. Now one of the things they didn't tell us, by the way, is if it's log base 7, we do know one of the log properties. Be cautious that log base 7 of 7 also equals the number 1. So what we're trying to use are the numbers 6, 9, and 7s possibly to figure out where 324 came from. Now a way to get 324 using 6 9s or 7 would be a 6 times a 6 times a 9. So I'm just going to restate this as log base 7 of 6 times 6 times 9. Now properties of logarithm says multiplication can be pulled apart into addition. So this is really log of 7 times 6 plus log of 7 of 6 plus log base 7 of 9. Now what I can do is I realize log base 7 of 6 is r and log base 7 of 9 is s. So this becomes an r, and an s. So we have r plus s, which would simplify to 2r plus s as the final answer. Now this one here is the same thing. We need to think about how to restate some of these values using 6s, 9s, or maybe 7s. Now 81 is going to be 9 squared. So let's just write log base 7, and I'm going to put 9 squared. Now 216 You may not know off the tip of your head, but it's actually going to be 6 cubed. So I'm going to write 6 cubed. Now remember, property of logarithms, when I have division, it's pulled apart into subtraction. So this is log base 7 of 9 squared minus log base 7 of 6 cubed. Also be cautious, we don't keep exponents in logarithms. They come forward. So the 2 will come forward and the 3 will come forward. So what we're going to end up writing for this is 2 times log base 7 of 9 minus 3 times log base 7 of 6. Again, what we've just realized hopefully is we know log base 7 of 9 is an S. Log base 7 of 6 is an R. So what we can do is we can rewrite this as 2 times S's minus 3 times R. And that's the answer. Now this next one is very similar, but they've changed the numbers up. Now we have log base 4 of 7 equals C, log base 4 of 10 equals D, and re-express this with C's and D's. Now be careful again, we have log base 4, so that means we could also use, if needed, know the fact that log base 4 of 4 equals 1. So the numbers we're trying to use now are 7, 10s, and possibly a 4. And we're trying to evaluate log base 4 of 49,000. So how do you get 49,000? Well, it's 49 times 1,000. So maybe I start by breaking it down like this first. But again, I'm trying to use just 7s and 10s. Well, I can rewrite 49 with 7s. That's just going to be 7 squared. And I can rewrite 1,000 using 10s. That's 10 cubed. So now I can pull the multiplication apart into addition. And we're going to have all of this in log base 4. Now lastly, be careful. The exponents have to come forward. The 2 and the 3 will come forward. So this will be 2 log base 4 of 7 plus 3 log base 4 of 10. Again, one of the things they've already told us, log base 4 of 7 is C. Log base 4 of 10 is D. So replace those and we're going to get 2C plus 3D. This one here wants us to rewrite this exponential equation, make it a linear equation, and they want it to use x's and the log of r. So really what they want us to do is take the exponential, they want us to write it as a logarithm, but it needs to be looking linear, which means no exponents are allowed. So one thing you can do is they want to say log of r. So let's make this the log of r. So I'm going to add a log to that side. But if I add a log to this side, I must do a log to this side, which becomes this right here, times 0.16 to the x power. Now one of the things we can do, property of logarithms, this right here that we see is just multiplication. So I can pull apart this term and this term. I'm going to write this as log of r equals log of 4.55 plus the log of 0.16x. Now do notice this is base 10, by the way, but it says it has to be linear. This is exponential right now. But we know in the log world, exponents can come forward. So what I end up doing is moving this forward. And when we do that, we're going to get the final equation of log of r equals log of 4.55 plus x times the log of 0.16. Now this is actually an acceptable answer, or if you wanted, you could go in your calculator and get the decimal answers for these two. If you do, here's what you get. Are these decimal values right here, which looks more linear. 9.5c and 9.6b condense logarithms and simplify or simplify log expressions and equations. So here they want us to find the value of this log expression where a and b are both positive. So basically crunch this down into 1. One thing I know is that subtraction becomes division. They are the same logs, so I'm going to put these together. This is going to be log of a divided by b divided by 100 a over b. Now, to get rid of this complex fraction, I want to get rid of this. So I just multiply by its reciprocal, which is b over 100a. And we're going to do that on both of these. Now, this simplifies quite nicely. Those all cancel. The b's cancel and the a's cancel. What I'm left with is the log of 1 over 100. Now I actually can evaluate this. Remember, this is just log base 10 and it equals something. So if I do our swoosh to go log to exponent, it's going to say 10 to some power equals that. So 10 to some power equals 1 over 100. The only way to move this number on the bottom would be to make it negative. And the only way to make a 10 100 would make it squared. So this would be a negative 2. So the answer here is negative 2. This one here, same thing, but now we have log base 5. We can bring together addition into multiplication and subtraction into division. Let's just do this first part here and then see what we get. So I'm going to do log base 5, and it's x squared over y, and we're going to bring together the 125y over x, and we'll come back and get that last part. Now when we simplify this here, we hopefully can notice the y's are going to cancel. That x goes away, so we're just left with 1. So now I have log base 5, it looks like, of just 125x minus log of x over 5. So let's now bring division into, or subtraction into division. So we're going to have log base 5, 125x divided by x over 5. Now to get the x over 5 out of there, what we would do is we're going to come in and we're going to multiply by the reciprocal of 5 over x and then 5 over x here. When we do that, those cancel, the x's cancel, and what we're going to be left with now, it looks like log base 5 of 125 times 5 equals something. So what I'm actually going to do next, though, to simplify this is notice that I'm going to have to rewrite it as an exponent. So I'm going to have to say 5 to some power equals this whole piece. So I'm just going to restate this with base 5s. Well, hopefully you notice that 125 is the same as 5 cubed. So what I'm going to say here is that this is 5 cubed and a 5 to the first, so this is 5 to the fourth. So let me just show you this. I'm going to say log base 5 of 5 to the fourth equals something. So now when I rewrite this as an exponent, 5 to some power equals this. 5 to some power equals 5 to the fourth. Well, clearly the answer has to be 4. Now, if you didn't see this connection of bringing these two numbers together as 5 to the fourth, you could have multiplied these together. It's just 625. So you may have said the log base 5 of 625, and then you just would have evaluated it. You would have said 5 to what power is 625? So it would have been 5 to the x power is 625, and from there you would still get that x would have been 4. 9.6c, write an exponential half-life model and solve. So 1 pound of leaves can decay in half every 16 days. How long will it take 5 pounds of leaves to be at 0.1 pounds? That is almost gone. Well, half-life model, remember, was our ending amount and our starting amount, but it's a half-life, so it's 1/2 there. And then the exponent was a little bit trickier on what we put in here. What on the bottom was the half-life, and this was going to be our time. So to set this up, here's how I'm going to start. We want to know when we're left with 0.1 pounds of leaves, but we started with 5 pounds. It's going to decay in half. Now, every half-life is 16 days. So if you think about, and you made a table for this, for example, if we started with 5 pounds and we said the time was 0, then in 16 days, we're going to be down to 2.5 pounds. Another 16 days later, or 32 days later, we'll be at 1.25 pounds, and it will continue to go on from there. So they want to know the time period or how many half-lives. So what I do in the exponent is I don't know the time, but I know it cuts in half every 16 days. So now I need to do is solve this equation. So this thing right here is one big exponent and one big power, so I have to get rid of the 5 first. To do that, just divide both sides by 5. And then you will get this equation right here. Now the power is all by itself, so the only other thing we can do now is rewrite it as a logarithm. So it's log base 1/2 of 0.02 equals this. So I'm going to write log base 1/2 of 0.02 equals t over 16. Now here, be careful, we have to do our base 10, so what I'm going to type in the calculator to get the answer is the log of 0.02 divided by the log of 0.5 for this value here. When you do that, here's what you get, is this equation here. Now, to get t divided by 16 by itself, I'm going to come on in and multiply both sides by 16. And after you crunch out that value, you're going to get that t is equal to 90.3 days. And you can take a gut check on that. We have to get down to 0.1 pounds. This is at 1.25 pounds even. And we're going to have to continue to keep cutting this in half. So it's going to take quite a bit to get that low. So that's where the 90.3 comes from.